Hello and welcome to the next edition of the BobCAD-CAM webinar series. Today's topic is 2D milling. The goal of today's webinar is to increase your understanding of BobCAD's 2D machining features for drilling, profiles, and pockets. Now, as you know, my name is Al DiPaolo. I'm the voice of the BobCAD After Dark video series. You can find me on Facebook, YouTube, Instagram, or really any other CNC forum that's out there. All right, so what are we going to be covering today? Well, we're talking about the version 31, which is our current version of the software, and we want to go over 2D machining features. We're going to review topics like geometry selection, what geometry you can select for different features. We'll talk about some tool types, different tool types that you can use, patterns of the profiles or pockets and different options that you have there, and additional CAM tree features like backplotting or cycle time estimate, things along those lines. Now, as you know, with BobCAD, you can expect fewer steps, better cuts, and more profit. And at any time, if you guys would like to request a one-on-one presentation specific to your parts, your machines, and your needs, call us at 877-333-4903, dial extension 123, and just request a one-on-one demonstration. Again, that's 877-333-4903, extension 123. All right. Now, while I get my screen set up here, why don't we do a quick shout out? If you can just let me know where you're from, just in the question area. If you can just type in where you're from and what machine you're running, that'd be great, just so I have a better idea of who we're working with here. So if you get a chance to just use the question area and type in where you're from, that'd be great. Don't be shy. Okay. All right, guys. All right, let's see. Okay, we got Jeff from Maryland. We got John from Kentucky. We got Alex from Vermont. Abe from Louisiana. We got Tony here in Florida. So very good. Hey, thank you guys so much for spending some time with me here today. Again, the goal of today's webinar is to cover 2D machining features. So let me go ahead and get started. Now, actually, I have a bunch of talking points that I'm going to review with you guys, but if you have any questions about 2D machining to begin with, any questions that you have about machining 2D parts, just go ahead and type that in the question area, just so I have an idea of some topics or questions that you guys typically have. This could be, and really any question that you have about 2D machining. If you have something, go ahead and type away. Otherwise, we're going to go ahead and get started. Now, I am bringing in a model. So let me ask you guys, are you typically, let's see, Art's here from Minnesota. Thank you so much for spending some time with us here today. Now, again, for 2D machining, are you guys typically working with solid models, or are you typically working with wireframe? If you can go ahead and answer that, that'd be great. Whether you're working with solid models or whether you're working with wireframes. Actually, this is not the file that I want to start with. Okay, wireframe, Abe says. Okay, let's see, Tony. When there's geometry in the same line, it's tough to separate. That's a good point, Tony. How do you separate solids from wireframe? Scott says he's working with wireframe. Alex says he's using the software for plasma and looking for more information on lead location and directions. Okay, Alex is saying he's working with wireframe. And I think Art said a little bit of both. And I think it's really common in today's marketplace that you guys could be working with either solids or wireframe. Okay, now the first area that I really want to talk about is drilling. Okay, drilling is very common, hole making process. What do you guys do? So one of the things that I'm going to do here is I'm actually going to create a new layer. All right, I'm working off this solid here. I'm going to create a new layer. I'm going to go to utilities, or I'm sorry, I'm going to go to create 2D, and then from here I'm going to go to extract edges, then I'm going to pick from whole solid, I'm going to project to Z0, and I'll click on my solid here. Okay, Now, the reason why I'm doing that is so that if you're working with wireframe, I've just created some wireframe for my part, okay? If you're working with a solid, okay, you can work with the solid directly or you can work with wireframe. Either scenario will work, okay? If you guys are just coming into the webinar, if you have any questions, just go ahead and fire away. Also, if you can let us know where you're from, that'd be great. All right, so I have a solid model here. There's a couple of different holes. Okay, at the beginning of every job, it doesn't matter whether you're drilling, profiling, and pocketing. The first thing that you need to do is to create a job. So we're going to go to the CAM tree, and then we're going to go create new job. All right. Now, when you do this, you're faced with different job types. Okay, in this example, we're using a milling job. All right. Now, yes, you're supposed to be seeing what I'm doing. I'm sorry. Okay. How about now, guys? All right. Sorry about that. Thank you, Alex. let me back up just a second here. Okay. All right. So we're in the version 31. Is that better? Yeah. Thank you so much. I forgot to press the play button. That will slow you down just a little bit. A little bit of a false start, but I would say that I'm probably not the only one that's ever happened to. Okay. All right. So again, we have our solid model here. I did extract the wireframe so that we have, whether you're working with a solid or whether you're working with wireframe, you can select either types of geometry. Okay. With our model here, again, we're going to go to our CAM tab. We're going to create a new job. All right. When we create the new job, it's going to be based off of milling, and we're going to choose our machine type. In this example, we're going to use a 3-axis mill. All right. Now, when we set up our job, we're going to run it through the stock wizard. The stock wizard's going to tell the software where the material is. All right. Once we've set where the material is, what we're going to do is pick an origin, and we use that origin for our machine setup. Okay. If there's any questions about setting up a job, the stock that you're using, or the zero, just go ahead and fire that away. The process, you just follow through the steps. It leads you through it. It shouldn't be too difficult, but if there's any questions about that, go ahead and let me know. All right. Now, once we get a job set up, we're going to have a milling job in our tree. We're going to have the machine that we're using. We're going to have the post processor that we're using. We're going to have a tool crib. We have our tool library. We also have our tool crib, which might be active tools that we're using in the job. We have our stock settings, and then we have our machine setup. Now, it's important to understand that BobCAD is a feature-based CAM system. What this means, it doesn't mean the software automatically programs your part, okay? What it means is we're going to create machining features based off of different categories, and then we're going to apply that to geometry sets, okay? If we right-click on our machine setup here, you're going to see a list of all the different machining features that are available. If we want to do drilling, we'll go to mill drill hole. If we want to do 2-axis milling, we'll go to mill 2-axis, okay? Now, any of these features that we click on, if we click on mill drill hole, it's going to start the mill hole wizard, all right? If we click on mill 2-axis, it's going to start the mill 2-axis wizard. All right. Now, within that wizard, we're going to answer all the questions about the machining process. Okay. What tools we're going to use, what geometry we'll want to select, and then also any of the machining features that we want to, or the operations, like the tool paths that we want to apply to the different geometry sets. Okay. So for instance, in this example, if I wanted to go over here and drill one of these holes, right, what would I do? Well, I would come into our machine setup here, and then I'm going to go to mill drill hole. Now, from here, I can select the geometry that I want to drill. So I'm going to choose select geometry, okay, and then I can select because I'm working with a solid, I can select these cylindrical tubes here that represent where that hole would start cutting, where it would end cutting, and then how deep it's going to go. All right, you'll see that selection in our selection manager. So if you make a mistake, you can remove your selection and then be able to go back and select what it is that you want to work with. Okay, once you have your geometry selected, the next thing that you'll do, like if you're drilling holes, it will read the hole size off the model, okay? It will read the depth off the model, okay? So you can make adjustments to that right now, but if we go to the next stage here, we're going to have our hole groups, and you'll see this with all drilling. Anytime you're drilling holes, it's going to be based off of hole groups. Hole groups allow you to drill holes that start and stop at different levels. Okay, you can see this one has a negative top of feature, and then it has our depth as a positive number. Because this is a counterbore, we'd really want to machine from 0. So we could either enter 0 here, or we could pick where we want to start cutting from. So we can say pick top, and then we could click on the top of our model, okay? We could say pick bottom, and then we can pick on the bottom of our model, all right? And then what that does is sets where it starts cutting, and then it also sets how deep it's going to go. Now, once we've selected our geometry and we've set our depths, the next thing we want to look at is the machining strategy. And this is actually what makes BobCAD a feature-based CAM system, because whether you're drilling a hole or cutting a pocket, you can apply multiple operations or multiple tool paths to that geometry set. Like in this example, if we want to create a hole here, we can first spot it and then drill it. Okay, so we have 2 operations that we're applying to that geometry set. Okay, if we click next, we'll see that we have our center drill or spot drill that we want to use, and then we have our spot drill parameters. And then we have the drill that we want to use, and then our drill parameters. Okay, if we're happy with all our settings, our last step would be to compute our tool path, and that will display that tool path on the screen. You'll see it here in green. That's the path that the tool is going to follow. Okay, now if we go back over to our feature here, if we click on our feature, okay, it will preview that feature. If I hit S on my keyboard, I can toggle my shading on or off. Okay, if we click on our feature here, you can see that it displays the hole size, and it also displays the depth of our feature. Okay, if we click on our geometry, what it does is it highlights the geometry that we selected. Okay, if we click on our operation, what it does is it highlights that operation. Okay, if we right click on an operation and we go to backplot, what this will do is display your tool information. Okay, so this way you can step through where that tool starts cutting, where that tool ends cutting. Okay, all right, we can do the same thing for this spot drill here. Let me turn that back on. Same thing for the spot drill. We can right click, go to backplot, and we can click through and set what our settings are. All right, so that's just a very simple drilling routine. Again, there's a counterbore on the top here. If we were going to machine this as a counterbore, let me go ahead and delete this feature. All right, we go through this again. We can say mill counterbore hole. All right, we can select our geometry. All right, we could select our cylindrical tube here. We can say OK. This allows us to type in the diameter for our hole. You can see it's reading, like I only selected one piece of geometry, so it's reading some of it. We can come in here and adjust what these hole sizes are just by typing in what the information is. We can pick where the bottom of the counterbore is. Okay, we can pick where the bottom of our hole is. All right, so this way you can use really when you're doing a counterbore, you're programming both the hole and the counterbore at the same time. When we do that, again, we have our spot drill, its parameters, our drill, its parameters, and our counterbore and its parameters. Okay, so at any time, if you want to go back and change what those settings are, edit your tool, edit your depths, you can just go to any of these categories here and be able to go in and adjust what those settings are. Is there any questions about that before I move on to the next topic here? No questions? Okay. All right, so let me go ahead and delete this feature. All right, let's come in here again. Let's look at tapping. Okay, so if you're going to create a hole, you go to mill drill hole. If you're going to do a tap cycle, you go to mill tap. If you go to counterbore, you're going to go to the mill counterbore cycle. All right, something that's important to understand is that if we do mill tap, okay, you're dealing with the same selection here. We can go to select geometry. You know, this time I'm just going to pick the wireframe geometry. So you could pick the surface edges or you could pick wireframe geometry. All right. I'm not too concerned with the hole diameter that shows up, okay, or the depth. When you're tapping holes, we utilize a thread library. Within this library, we have all the different thread types, and then we have a variety of different thread sizes that you can work with. All right, this is a database that comes with the software that you can customize, and it's really used to optimize your tapping routines. Okay, allowing you to set your default pre-drill amount. It also allows you to set the tap that you're using and other information that we use, like if you're doing thread milling and those types of operations. Okay, so again, we have our feature that we selected. We have our different strategies here, so you can see we're going to spot, drill, chamfer, and tap. Okay, and again, this is based off of our thread library. So we can go in here and we can pick different pre-drill sizes automatically. And then we can also set where we start cutting and where we end cutting. Okay. Now, let's say you don't find the thread type or size in the database, you can always add to the thread library. If we go to the CAM tab here, you're going to see there's a variety of libraries that come with the software, and you can always add to these. Okay. So if we go to the thread library here, here you're going to see all the different categories. If we go to the UNC, you'll see the quarter 20 is here. If we want to modify this, we have the major, the minor, the pitch, the thread angle. If there's a taper, like if you're using MPTs, okay. And again, we use this information for tapping cycles, and we also use this information for thread milling. Okay. All right. So again, whether you're going to do a counterbore, whether you're going to do a tapped hole, when you come into the CAM tree here, all right, you're going to pick the category that makes sense. Now, if we look at this section here, we have a countersink, right? So sometimes you need to countersink holes. So let's go ahead and delete this feature here. How do you accomplish the countersink? Well, you can do your drill hole. You can select your geometry. Again, I'll pick these two sections here. All right. It's going to read the hole size. It's going to read the depth. We're going to tell it that where we want to start cutting from. So I want to start cutting from here. We're going to tell it how deep we want it to go. So it's going to go all the way down to the bottom. All right. When we do our machining strategy, this is going to be a hole cycle. So you have your center drill and your drill. Okay. From there, we can go over to our center drill. And I know some people, they don't want to use the center drill. They want to use a spot drill. That's totally fine. If we go into our tool crib here and we add from the library, you'll see that there are some spot drills that are built into the software. Okay. If you don't see the spot drill size that you want, you can add one in very easily. You just click add and then you type in the information for that. Okay. All right. In our case, we're going to pick our spot drill here. We're going to say okay on that. All right. And we're going to look at our center drill parameters. Now, there is a calculator built in here. You'll see this for all the drilling cycles. There's calculators built in. What this allows us to do is to adjust our depth size here. And based on adjusting our depth size here, what will happen is the center diameter will change. Okay, so there's a built-in calculator so that you can figure out what the depth needs to be in order to get the countersink at the proper amount. I'm just going to compute this here. All right, we can come over and backplot this. Obviously, this tool isn't the right size for this countersink. It would need to be a lot larger, which is why some of the calculations were coming up wrong there. But you can see how you can use your spot drill to come in there and do the countersink, and then we can come back and do the drilling cycle. Okay. Now, regardless of whether you're drilling, pocketing, or profiling, the last thing that you would do after you've set up the job and you've picked your tooling and you've entered your parameters, maybe you've simulated the job, you might come over here and post your code. When you post the code, you're going to get a preview of the code in the posting window. Okay. If you right click on the code, you can launch it in an editor or you can save it out from there. I usually preview the code so I can see what's going on, make sure that I have the right post processor. Okay. All right. So that is just a little bit about drilling with BobCAD. Now, one of the benefits of working within the BobCAD system is the ability to save and load your machining features. It's very likely that the parts that you're machining dimensionally will change, but feature-wise, they're going to stay the same. Okay? So if you can reuse features for different hole sizes or different machining cycles, it can really shorten your programming time. Now, specifically when it comes to drilling holes here, okay, so if we go over our feature here, we can save this feature to a library and then we can pull it up later. But it's important to understand that anytime you reselect geometry for a drilling feature, there's a certain amount of logic that goes through the software to pick tool sizes and just things that happen in the background to aid in the processing of holes. And if you're going to reuse that machining feature, you may not want to run through those processes. And the way that you avoid that is when you're under the parameter section for drilling, you can uncheck use cutting conditions. When you uncheck use cutting conditions, when you save this feature, it will use the same depth values that you've inputted here. Okay, so that's a pro tip for you. As you use the software more, I'm sure you'll be saving and loading features, and that's the best practice for saving and loading hole cycles here. All right. Now, I know Tony's got a question about drilling here. Yeah, I'm probably going to address that one a little bit later, Tony. I'm trying to cover some of the basics here before I get into that particular question. Other than Tony's question, if you have any questions about drilling, go ahead and fire away. What I'm going to do is actually turn off the solid model now. Okay. I'm going to rerun the stock wizard just based off of our wireframe here. Okay. I'm going to come in and set my 0 again at a different location. All right. So not everybody works with solid models. If you're working with wireframe, you can work with wireframe just the same as you can work with solids. Really, when you're coming and you're drilling holes here, let's create some points. Let's just say at arc center. You can use the arc geometry to read hole sizes, but you can also just use points and tell the software where you want it to go. So you could say drill hole, and you could pick all these hole locations, all right, as such. Maybe those are the ones that I want to drill, okay? And then I can come in here and I can type in whatever size that I want, and I can also type in whatever depth that I want, all right? So you can work with points, you can work with arcs, you can also work with surfaces. You can apply your strategy here, all right? If you want to get into, you may be thinking about different cycles like peck drilling and things like that. We can come down to peck here and change the cycle type, all right? And then that will allow you to be able to drill these holes. The first one is going to come through and spot all the hole locations, okay? The second one is going to come back in a reverse order, and then this is going to come through and peck these holes out, all right? So whether you're doing like a G81 or a G83, right within the feature, you can come in here and adjust what type of cycle that you'd be utilizing, okay? All right, unless there's any additional questions about drilling, I'm going to move on to the next feature here. Let's see. All right, so I want to look at this part here. This has to do with 2D machining. I want to look at profiling. Profiling is probably a really common routine that you're going to run into. All right, so we're going to do mill job 3-axis. We're going to run our stock wizard here. We're going to set where our 0 position is. Okay, you can pick any position that you want. I'm just going to pick this location here. All right, now we're going to come into our machine setup. We're going to right click. We'll come down to mill 2-axis. All right, from here we can select our geometry, what it is that we want to work with. The first section I'm going to pick on is this section of the model here. All right, if I click on my profile chain, it will show me where it's going to start cutting and where it's going to end cutting. It shows me the direction of cut. All right, when I look at my depth, I could enter my depth or I can pick it up off the model, and then we can choose OK. All right, so we've done our selection there, working off the solid directly. The next step I would look at is the machining strategy. In this example, we're talking about a profile. I'm just going to look at the profile rough. Okay, when we look at the profile rough, we can set our tool size. All right, now, kind of when you're dealing with your tool size, you can just type in the tool size that you want to use. Okay, so if you want to use a 1/4-inch end mill, you can type in a 1/4-inch end mill. If you want to use a 1/2-inch end mill, you can type in a 1/2-inch end mill. And if the software doesn't have that tool in the library, it will automatically create that tool. Okay, so you don't have to spend a lot of time setting up your library. You can actually just enter the tool sizes you need when you want. Okay, now if you want to choose a different category of tool, that's when you would go to the add from tool library. Okay, under this category, these are all the different end mills that you could pick. You could also go to one of the other categories. If you're doing using a T cutter, maybe there's an O-ring groove that you're machining, a dove mill, a lollipop, or a taper. You can pick all of these tool categories for profiling. All right? Okay. So in our example, we're going to just use a 1/2-inch end mill, which is fine. I'm going to just compute the defaults right now. And what we're going to see is the tool is going to come down over here, and then it's going to follow this profile and come back up. All right. So that in itself is okay. That's a standard profile. There's a number of different things that we can do with this profile here. Okay. We might want to take additional passes. You can see we're on the corner here, and we need to remove additional material. All right. So how do we go about doing that? Well, if we edit our feature here, and we go under patterns, you'll notice that there's different patterns we offer for profiling. You have a standard profile. You have contour ramping, which will ramp down. You can use this for helical milling, slot making, roughing shapes as well. And then we also have side roughing. Side roughing is the one that I want to start with. A lot of times you may want to walk your tool into a profile. What you can do is tell it how much material maybe is left, and then you tell it how many passes you want to take that in. And to figure out the width of cut, it's stock remaining divided by number of passes, and that tells you what the width of cut is. All right, once we're done with that, we just hit compute to update our toolpath, and now you can see that we're taking multiple passes over here. Now, do you guys, do you think using profiling with side roughing is something you would use? If you can just comment yes in the questions area, that'd be great. If you don't think that's something you would use, just go ahead and write no. It looks like Jeff said, yeah, I would use that. Okay. All right. So that's an example where you're on a corner. Okay. Let's go ahead and close this. Now, let's say that we want to change what geometry we selected. Right now, we have this geometry picked. If we want to select different geometry, Scott says yes, absolutely. What I'm going to do is move from this side over here to this side over here. All right. So in order to do that, I'm just going to remove my geometry. I'm going to reselect. I'll pick the edge that I want to work with. Okay. I'll look at my profile chain. I want to make sure that it's cutting in a clockwise direction. If I needed to change the direction of chain, I can just hit this reverse direction here, and that reverses the direction of the arrows. Okay, so if we click this, it goes that way. If we click this, it goes that way. The other way you can do it is you can just click on the arrow itself. You can switch what direction it's going in by clicking on the arrow, and then that will change it as well. All right, again, we want to look at where it's going to cut to, so we're going to click on Pick Bottom. We'll click where we want it to cut to, and then we'll choose OK. All right, now what if we want to measure? Like this one, I didn't bother measuring. What if we want to measure what this distance is? Because by default right here, you can see I think I had it set to 1 inch. And we may not know the distance between here to here. All right, and this is really common for 2D machining. You might need to get some measurements. Sometimes you're working off a print, and you can read the print. Other times you may want to measure between 2 points. Okay, if you right-click, measure 2 entities, this will allow you to pick 2 points off the screen, and then it will give you the distance. So we know that's 2.75. All right, so now we know that's what we want to put into our machining feature. Okay, so we'll come back to our feature. We're going to right-click, Edit. All right, we're going to go to our patterns, and then we'll type in, I think it was 265. And then what we can do is set how many times, how many passes we want to do that in, and recompute. And then now we can see that we're able to cut this section here. Again, you can make adjustments as you need to. All right. So this is another example of where you might use a profile with side roughing. Okay. All right. Let's go ahead and remove this selection and reselect. This time, let's select around this slot here. Now, there are a couple of ways that you could do this. You could pick one edge at a time to work your way around the slot. That's one way to do it. Another way to do it is we could just pick this face as well. So you can pick the edge, you can pick the face, you have constant Z. There's a couple of different selection methods, but we're saying this is the area that we want to cut. Again, we're going to pick how deep we want it to go. All right, we want to look at our chain here. Which way is this cutting? You can see that it's going counterclockwise. We want to make it clockwise so we can reverse that direction here. If we wanted to change the lead-in position, we could just click on a different section of our geometry. Okay. Once we have our geometry selected, we can choose OK. Come back to our feature here, recompute, and then here's another example of where you might use side roughing to work the tool in from the outside. Now, maybe we want to change the tool size in our settings. We can just come back to the feature. Maybe this was a 1-inch end mill. Maybe we want it to go 1.5 inches out. We want it to take 10 passes. We can recompute here. And then this is how you can see this will work its way in from the outside. Definitely a very useful feature, side roughing. Okay, if you guys have any questions about side roughing, go ahead and let me know. The main topic that I have here is geometry selection. Now, I know I work directly off this model. All right. Again, if you're working with wireframe, let me remove this and recompute. I'm going to convert the model to 2D. So I'll do extract edges from solid, project to Z0. Okay, this will give me all of my wireframe. Now, I know Tony brought it up a little bit earlier. You'll notice, Tony, every time I create wireframe, I always create a new layer and make it active first. The reason why I do this is it makes it really easy to separate out or to isolate your geometry. So you can pick or turn off the solid and just work with the wireframe. Okay. Now, if you're working with the wireframe, again, because I extracted the wireframe, you may get a print in that's just wireframe like this. Again, because I've made a change here, I'm going to run my stock wizard again. Okay, I'll click recalculate. I can enter how deep the stock is or how much material I'm working with. There's additional offsets that you can type in if you want to add additional offsets. Again, we can set our origin, which is our 0. So we just click in origin, and then we pick where we want our 0 to be, and we choose OK. All right. So now, even though we're working off the wireframe, we have the same options available. We can just come in here and select. We can pick on our single edge here. We can type in how deep we want it to go. We can set what direction it's cutting in. Okay, and then we can recompute the toolpath in order to update the change. All right, okay. So again, if you're going to use a different type of cutter, right? If you want to use, a T cutter, a dove mill, taper, you just go to the tool crib. You'll see the categories of different cutters on the side here. You're going to pick the category of tool that you want to use. You can add from the library. There's a bunch of different ones that are in here. These are all smaller tapered end mills. Okay, and then I can use that for my profile here. If I backplot it, you'll be able to see the tapered cutter and how I would work my way over. All right, now if you guys have form cutters or specialty tools, that's supported as well. Go ahead and comment if you have specialty tools. I'm just curious how many of you may use form cutters, but form cutters are supported as well. You can customize your tooling. You can customize your tool holders as well. Now you'll notice most of what I'm doing here, I'm just backplotting within the CAD window. Again, this is just a quick and easy way for you to be able to see what's going on. All right, some other tools that we have here, if you go to your milling job and you go to your toolpath statistics, this will give you some information about your toolpath, things like minimum, maximum distance, the feed rates you're using, and also the speeds and feeds, the cycle time that it would estimate based on the speeds and feeds that you've used. Okay, so this is great for quoting jobs or just planning as well, getting some information about what's going on in the job and how long it might be taking. Okay, there is solid simulation as well that comes with the software. If you're using version 31, you will have solid simulation, and this way you'll be able to see the tool and the holder. You'll be able to see exactly what's going on with the routine in 3D, and this will help you catch any problems, but it'll also help you visualize the exact process of what you're doing. Okay. All right. So that is side roughing. Let's go ahead and copy this guy, and then we're going to paste him. We're going to say no. What we're going to do now is select this slot here. Actually, there's some extra geometry. When I tried to chain it, you can see that it didn't go all the way around. It's likely because there's double entities there when I extracted the wireframe from the solid. Okay. If you're working with DXF files and they're not chaining, or like you're trying to select a profile around and it doesn't go all the way around, you may need to clean up that geometry. If we go to utilities, there's a cleanup and optimize routine here. This will get rid of double entities and clean up your geometry. And you can see how it gives you a report back to tell you the changes that were made to the geometry. Okay. All right. So if we go back into the CAM tree here, we reselect our geometry and we chain select this now, you can see how it goes all the way through. Now, if you're not sure what a chain select is when you hold shift on your keyboard and you left click on a group of entities that should be connected, like this slot. All right. The reason why I want to go to this one here is I want to change the pattern. Okay, so we had been using side roughing. What I want to do is go to contour ramping, and contour ramping allows the tool to ramp down as it gets to the bottom. Let me change my tapered mill just to an end mill. We're going to use like a 1/4 inch here. We'll say okay. All right. Now, all right. So we've set the pattern to contour ramping. What we're going to do is go to the parameters here, and then this is where we're going to either say the angle for the ramp or the depth per pass. And the one thing that, whether you're new to BobCAD, whether you're new to CAD-CAM, the thing that's really important for you to understand is that within these machining wizards, these are all the options within the toolpath. Okay, so don't get overwhelmed. There's a category here, and you're just going down the list and you're answering questions. Okay, so based off of your answers will affect your toolpath. And if you don't like the result of your toolpath, you can just go back to the wizard and make changes. Okay, so it's really a very fluid workflow, very smooth. Most of these options in here, if you click on any of these, they're going to give you a visual aid so you can tell what's going on with that feature. Okay, so in this case, we're doing a ramping routine. We're going to recompute here. And we can see how the toolpath is going to, let me go to a top view and then a front view. You can see how the toolpath is going to ramp its way down. Now, another thing that, I kind of want to review has to do with your machining features. Okay, so you can see there's a list of them that we're going to build out on this machine setup here. What we want to do is go to this first feature, right click on it, and we're going to choose blank toolpath. And what that does is it hides the toolpath. So as you continue building your machining features, you can isolate and only look at one at a time. Okay. All right. So if we go back to a front or top view, you can see this is our slot. If we go to a front view, you can see that it's ramping down. If we backplot this, okay, you can see that the tool is going to ramp its way down to get down to the bottom. If we post this, different machine controls support different codes. We should see that we're getting helical movement to get down to the bottom. If your machine doesn't support that, we can turn that off in your posting. But most of the time, you're going to want shorter, more efficient programs. And the helical ramping does a good job of that. Okay. All right. So that is a ramping routine. Again, we can come into our feature here. If we want to adjust the settings, we can go to our parameters. Maybe we wanted a shallower angle, so we can adjust what that angle is, and then that will change our profile. Now, it's important that this isn't just for slots. You can use this on all kinds of areas of your part. If I remove my geometry and select the outside shape here, sometimes you may want to ramp around the outside profile. And you can see that you can do that as well. Usually you may be doing this with an irregular shape, and the idea is to clear a bunch of material very quickly. Okay, so ramping is not just for slots. You can use it for profiles. The other thing you can use it for is for just like almost like a boring cycle. If you want to bore out some holes, you could use contour ramping for that as well. All right. Okay. If there's any questions about that, go ahead and fire away. I know earlier on there was a question about lead types. So like if we look at our feature here, you can see we highlight the feature. It shows the feature depth. If we click on the geometry, it shows us what geometry we selected. If we go to the operation, it highlights the operation. Above the operation, it says default chain start point. The default chain start point is where the tool would start from and what direction it would be. Contour ramp is the fastest way to get the job done. Yeah, I would agree. In a lot of cases, contour ramping is very useful. So that's a good point, Art. Thank you for pointing that out. Okay, so we do have our default chain start point here. This is where the lead-in position is. If we want to change the lead-in position, we can right-click on this, we can modify, and we can move it to another location. Okay, if you make a change to a selection or your settings in order to update the toolpath, you do need to right-click on the feature or the operation and recompute the toolpath. Okay, so to change the start position, default chain start point, you can just change it where you want it to be. All right, now if you want to change the lead-in style, if we edit the feature and we go to leads, these are your lead in and lead out settings. So right now I have it set to vertical. You could have parallel. You can have it come in at a right angle. You could also do circular or a blend. So you have a variety of different options here. I'll do a tangent circular lead in and lead out. And then we'll just see that the tool comes in tangent to the profile and then works its way around and then comes out. So if you guys want to adjust your lead styles, you just go to the lead tab. If you want to adjust your pattern, you go to the pattern tab. Okay. All right. So that is a little bit about contour ramping, so I showed you contour ramping and I showed you side roughing. These are very useful features that you can use in your day-to-day 2D machining. Okay, the standard profile I didn't show you. The only difference with the standard profile is it just walks around the wall. That's it. Okay. Now, if there's any additional questions about that, go ahead and fire away. Otherwise, we'll move on to the next file here. Okay. Actually, let me drop this one in here. This one here, again, we're working off a solid. Okay, this is definitely a variety of scenarios where you might use some ramping routines. Okay, like these slots here, you may want to come in here and to ramp out those slots. So, the first thing you may need to do is either measure the model or create some dimensions so you can figure out some tool sizes that you might be using. Okay, so if you go to evaluate and measure one, you can click on any edge of the model and then it will populate that information under the measure entity window. Okay, so this way you could, read the diameter that you're working with or what have you. Sorry, I got a call coming in, guys. I'm going to let that one go. So sorry about the interruption. Okay. So we can measure this radius here, and then that will give us information about it. Or you could click on this line here, and then that's going to tell you what the depth is. Okay. So before you get going, you can kind of get a feel for what's going on with the part. All right. We'll come back over to our CAM tree. We're going to do mill 2-axis, select geometry. In this case, I'm actually going to pick the bottom surfaces of these two here. All right, I'm going to pick the depth. I'm going to tell it to go the depth that I want it to go. All right, and then when I look at my chains, I want these going counterclockwise. That looks good. All right, we'll come into our machining strategy. We're going to do a profile rough. All right, we're going to say that this is 125 end mill. We're going to do contour ramping. We're going to tell it a depth per pass. And let's go ahead and compute. And then these two will come in here and ramp those slots out. Now, if the width of the slot is the same size as the tool, all right, so you can see how this is ramping its way down. But if the width of the slot is the same size as the tool, all right, so we can make this, let's make it a 1/4 inch. Let me just zero this out and recompute. Then what it does is it will ramp back and forth down the center. Okay. All right. So if the width of the slot is the size of your cutter, it ramps back and forth. If the width of the slot is greater than the size of the cutter, then it profiles and ramps its way down. Okay. So those are some slots there that we can come and attack. All right, if we come in here, let's do another 2-axis routine, select our geometry. What I'm going to do is just right-click on this edge here, and I'm going to choose constant Z, and then that will go all the way around. That's another, if you're working off of solids, that's another selection method, is to right-click on your surface edges and choose constant Z. All right, now again, we can pick how deep we're going to go. We have our chain start point. I'm just going to move that over here and set the direction. All right. We may come in here with a larger kind of like feed mill or something along those lines. We'll just make this 750. Let's see if that's enough. We'll do contour ramping. We'll set our increment per pass. Let me compute here. And you can see how we'd be able to ramp around this profile and work its way down. And we may be, this, what do I have, 750? You might be using a larger tool than that. And then you can have this just ramp its way down in order to clear that material very quickly. Okay. Again, if you want to come in and adjust the lead style. You can use different lead styles as far as how the tool is approached and how it comes in and out. Same thing here. If we want to come in and do some slotting here, we'd be able to do that as well. All right, so we got to a couple of different profile types. If there's any questions about profiling, go ahead and fire away. Otherwise, I'm going to move on to the next one, which is pockets. Let's see here. All right, let me drop this one in. Let me close this file out. You know, and if you guys don't mind answering as well, I mean, this is a webinar. We actually demonstrate the software the same way. If you like this format, this webinar format, go ahead and comment that you like webinars. Let me know if that's something that you guys work with well and you like this format. If not, no big deal. Okay. All right. So now we're getting into some pocketing, and there's a couple of different types of pockets that we're going to deal with here. Jeff says, I like webinars. Very good. Abe says, I like webinars. Very good, Abe. I like them too. Okay, so we have our solid here. And, you know, for most 2D machining, you can work off of surface edges directly. Tony, thank you so much. But sometimes what you need to do is you need to create some wireframe. Okay, so the first type of pocketing that I want to do is I want to talk about open pocketing, and there's a number of different types of open pocketing. Outside in, inside out. You have a lot of different options. Okay, so I'm going to come over here and create a new layer. And on this layer, I'm going to do a couple of things. One thing I'm going to do is I'm going to create the wireframe for hold on a second here. Looks like my system is frozen up for a second. Not exactly sure. Give me just a second while I figure out what's going on here. Webinar after dark with interaction. Yeah, I definitely like the interaction for sure. I don't know exactly what's going on here. Yeah, it's kind of strange. I'm not sure exactly what's going on. I think I'm going to just kill it. It's right in the middle of a process or something. You know, one of the things that I've noticed here with our server is we run different checks with our server, and sometimes it tends to eat through the memory. And memory is pretty important, as you know. And if you run out of memory, you run into trouble. Okay, so I'm not sure exactly what the story was with that one, but let's kind of keep going here. Okay. Okay, so what I had to do, it got stuck in some application, so I killed it and started it back up. But we have open pocketing we want to talk about. So, you know, a lot of pocketing, you can base it just off of surface edges. If it's closed pockets, like if we were going to come in here and cut this star, no problems doing that based off of selecting this outside edge here. Okay. What I want to talk about is open pocketing. So what I'm going to do is I'm going to create a new layer and make it active. So this way I can isolate my geometry. And there's a couple of sets of geometry that I want to grab. I'm going to grab this one and this one first. Okay. So these give me two boundaries. The reason why I convert to wireframe is I need to tell it what side of the model is an open side. So let's go back to here and get the job going. All right, so we'll do a new job, milling job. We're going to run our stock wizard. Okay, we're going to set where our zero position is. All right, we're going to come in and load our 2-axis routine. We're going to select our geometry. The first thing we're going to do is select these two faces. Okay, then we're going to come in and set how deep we want it to go, and we'll choose OK. All right, our pocketing strategy, we're going to come to pocket here. All right, we're going to set our tool size. All right, and then we have our different patterns. And the different patterns are the different types of pockets that are available. Okay, we're going to do just a standard offset out type pocket. We're going to compute our settings here. It'll take a second to calculate, and you can see that we get our pocketing routine. Now, so there's our feature that shows the depth. This is the geometry we selected, which is the faces, and then that's our pocketing toolpath. But the goal behind a pocketing routine is to clear the material from within a boundary. So if we run this through here, actually, let's do a simulation on it. Okay, so if we run this through and we take a look at what happens here, you're going to see that it doesn't actually clear all the material. Okay, and the reason is the tool is trying to stay inside of that boundary. So if the tool is trying to stay inside of that boundary, how do we get it to go outside of that boundary? One of the ways that you could do that is to come in, create your wireframe and then adjust the boundary. Maybe we move this out further. Maybe we move that out further. Okay, so there's a couple of different ways that you could do that. Probably a simple way to show here would be to do like a parallel line by some distance. Okay, and then now that you've done your parallel line, you could come back and trim that up. So we'll do strings here. So you could say from here to here to here to there to there. And then strings. So we can say from here to there to there to there. All right. So we've edited the boundary. Yeah, it's a TD. I agree. I don't think this is the best way. I'm just showing a method that you could use. All right. So it does take the time of creating the additional geometry, and what if you change your tool size and you got to go back in and do it all over again. But that is one way in which you could get the tool to cut out past the edge. Now, the other option that you could do, let's go ahead and undo that. All right. The other option you could do is use what we call open pocketing. Okay. So with open pocketing, you can select the open areas of the pocket. Okay. These are the areas we want the tool to come in from the outside. Okay. So we select those areas and then we change their attributes from a solid line to a dotted line. All right. So now we're saying that those are the edges of the stock. Okay, Jeff? All right. Now we're going to come in and reselect that geometry. So I'm actually going to clear everything and I'm going to reselect it. Okay. And I'll recompute. And then what we're going to see is that the tool actually goes outside of those boundaries automatically. Okay. So this is what open pocketing is instead of the tool being confined to that boundary, now the tool can go outside of that boundary. All right. If we run simulation again and we take a look at our result, we're going to see that the tool is now going to clear that stock all the way through. Okay. All right. So that's one type of open pocketing. This is a two-sided open pocket. Now, you do see the tool picking up and moving down. So maybe you're saying to yourself, well, how do I get the tool to stay down? If we come back to our feature here and we go to our patterns, you can see right now it's set to one way. What we can do is uncheck that and recompute and then now it's set to two-way, so that keeps the tool down. Now Jeff says, how far does it clear the stock, one tool diameter? I don't know the math behind it, but greater than what it needs in order to clear the edge. So it's a value that is hard-coded into the background, okay? So it's not something that you have to think about. You know that it's going to extend past the edge of the part. You can clearly see that in this example here. You know, if we backplot this and we get it down, well, we probably could even measure it to figure out, but you can see it's greater than the diameter of the cutter to get it out there, okay? All right, so this again is a two-sided open pocket. This is like an offset style here. You know, if you're dealing with harder materials, you may want to use some of the more modern cutting strategies. This one's called adaptive. There's a lot of different names for this strategy, but adaptive is a form of tricordial milling. This is where it does more side roughing, the loopy tool paths that you're used to seeing. You know, that's what our adaptive routine is. There's a lot of benefits to this style of cutting strategy, but of course it's going to depend on the material you're working with, and also your equipment as well. Okay, so that's a little bit about two-sided open pocketing. Now, here's another scenario where, you know, we have this boss in the center here, and we want to clear the material down to the boss, okay? How do you go about doing that? Well, again, I'm going to create a layer here, okay? I'm going to extract the wireframe for this edge, okay? I'm also going to come in here, and I'm going to create a rectangle based off of 2 points. So I'll go ahead and grab this corner here, and then we'll grab that corner there, and that will give us our two boundaries here. Now, you know, as we're working through the parts, we have extra toolpath on the screen. We want to blank it out. So we'll go to the CAM tree, and we can just blank this out so that way we don't see it, okay? Again, in order to tell the software that this is an open area to come into this boss, what we're going to do is select our profile here, and then we're going to change this from a solid line to a dotted line. Okay, so that way the software knows that that's an open area. Well, I'm just going to copy and paste this feature so I can use the same settings. I'm going to say no on the depth value. I'm going to select our boundaries here, and then I'm going to pick how deep I want it to go, and I'll choose OK. All right. So now we can use this same adaptive style strategy to have the tool work in from the outside, clearing down to that boss. Okay, so this one is a four-sided open pocket where we have it going from the outside to the inside. Okay, now what else might we want to do here? You know, we have this this circle here. Let me blank this out. We have this circle in the center. Now this could be a counterbore. It could just be a circular pocket. But we have a spiral pocket that we could use for that. All right. So again, I'm just going to copy my feature here. I'm going to paste it. All right. I'm going to say no to my depth values. I'm going to come in here and select this circle. I'm going to tell it how deep I want it to go. I'll edit what my tool size might be. I think that will work. Let's go to our standard pocket, and then we'll say use spiral for circular pockets. Okay, and this will start right in the center of the hole, and then it will spiral its way out. Okay, so it will start in the center, and then it's going to spiral its way out. So we can use that to clear material. Again, this is for like counterbores or circular pockets. Spiral does a really good job. Now, the other thing, now that we've cleared this pocket in the center, you know, now we want to clear the rest of this material here. And again, there's a variety of different ways that you could go about doing that. What I want to do here is show an open pocket where you're going from the inside out. So it's very important to understand and go from the outside in, but you can also go from the inside out. Okay, so I'm going to just create another layer here. I'm going to create 2D, extract edges. We're going to click on this face here. Let me do, okay, so let me undo that, and let's click on this face here. All right, let's blank that out. So that way we have our star and we have our circle. What we're going to do is take our circle and we're going to make that our dotted line. So we're saying there's a void in the center, and then we want it to work its way out from there. Okay, so we'll come back to our CAM tree. We're going to copy this feature. We're going to paste this feature. All right, we'll select our geometry here. As far as our depth value, we'll pick it up off the model, or you can just type it right in. All right, we're going to come in and edit this. Again, this is going to be an advanced pocket. This is adaptive. Okay, we'll recompute, and then what it will do is work from the inside of that void out. So you can go outside in, you can go inside out. All right. The other thing is that when you deal with pocketing, sometimes the tool doesn't fit all the way into the corners. So you may need to come back and clean up this wall here. Now, of course, you can do profiling with side roughing, but another option that we have in here is called rest machining. Okay, and again, this is where the power of the feature-based CAM can be really beneficial for you, because you can create a feature that has both the rough pocket and the rest pocket built into it, and you can save this and be able to use it on future projects. We're going to just drop this one down to a smaller tool size. Okay, we're going to do an adaptive rough here. All right, but what we'll do is we'll turn rest roughing on. The software will look at the previous tool that was used. Okay, we can compute this, and then it will compute the rough routine, and then it will compute the rest rough routine with the smaller tool to go in and cut where the larger tool couldn't fit. If you're working on letters, Jeff, and you want to rough out a larger area and then come back with the smaller tool to clean up what's left over, rest roughing is a really good way to attack that. Okay. All right. So that is a little bit about the pocketing. Now, another thing that I wanted to talk about that has to do with pockets is your start point. Yeah, I had a feeling you might like that, Jeff. Another topic that I wanted to talk about has to do with the start point location for pockets. Like, let's go back over to this one here. Okay. I mean, I get these more so. First off, you can set a pocket start point. All right. And it's important to know that you can do that. A lot of times you may want to drill a pilot hole, and then you want the tool to start in that pilot hole. Okay, how do you do that? Well, if you look at your pocket feature, you can see there's a default chain start point. That has to do with your profile and where the profile is. But then you'll also see that there's a plunge point here. Okay, so the plunge point you can use to specify, where that tool is going to come in from if you had pre-drilled a hole. Okay, you can do this on one boundary at a time. Let me turn this off for a second. Okay, so let's look at this one here. What I'm going to do is I'm just going to join a line between here and there. Okay, and then I'm going to put a point on the midpoint of that line. All right. Let's get rid of this. Okay, let's make this back to a solid line. Okay. All right, over here, let's remove. I'm going to change this pattern to just like offset out. I'm going to select my geometry here, and then we'll compute this. All right, so you can see that the tool, that actually didn't go where I wanted it to go, but you can see the tool starts here and then works its way out. We may want to pick a different position for that tool to, something's come up. I have to leave now. The webinar is very helpful. Good job. Okay, Joseph, see you next time. All All right, so what I'm trying to do here is set where the tool starts. You can see the tool, it picks a position now, and it starts from that position, then it works its way out. If I wanted to choose a different position because I pre-drilled a hole or something like that, I can create a point. Now, I did create this point here, but I made a mistake, so I'm just going to delete that. I'm going to create a line between here and between there, okay? And then I'm going to put a point, on this entity right there. Okay, so this point, the whole reason why I've drawn this is that point represents where the tool would start in this pocket. Okay, so we'll come back over to the cam here. We're going to pick our plunge point. It's important to understand for some routines where the point is located in Z matters. So if you do an adaptive routine, it's where that point is in Z. But we'll pick this location and we'll recompute here. And now you can see the tool starts at that point location and then connects and works its way out. Okay. All right. So that is a little bit about the pocketing. We have our start point location. Now, a couple of other topics that I want to cover about the CAM tree. We got a handful of people that are still in here. The webinar was scheduled from 1 to 2. We're a little bit over. It always surprises me about how quick the webinars go, and there's still so much to cover. Okay, if we get over to the CAM tree here, a couple of things that I want to review with you. Okay, number one, we've used this pretty much the entire webinar. If you right-click on any of the operations and you go to backplot, this is how you can display where your tool is, where it starts, where it ends. This is a quick reference to help you understand what's going on with your routine. Okay, that's number one. Number two, you have toolpath statistics. This is very helpful because it gives you the extents, the min-max of your toolpath. It's also going to give you cycle time estimates that you can use for process planning and just getting an idea of what's going on with the routine. All right, so you have toolpath statistics. Now, another one that I didn't really touch on in this webinar is the toolpath editor. And if you right-click on any operation, you can go to the edit toolpath. All right, and the toolpath editor has a bunch of tools that you can use to edit your toolpath directly. Now, most systems, when it generates toolpath, like BobCAD, it generates it in the background, and you don't have the ability to select or edit that toolpath. Okay, that's most systems. With the toolpath editor, it gives you the ability to select and modify and move. There's a bunch of different things that you can do with this toolpath editor. You can convert your toolpath to geometry. You can modify the feed rates. You can move their locations. It's pretty powerful. As an example, let me turn this off. Let's say that, maybe this pass of the, we know there's material here. There was a video I was watching that, they're facing off the part, but this actually has a bunch of material here. So, what they wanted to do was slow down the feed rate in that section. And with the toolpath editor, you could do that. You could say modify attributes. We can go through a little click window here. This is kind of... All right, so I selected the group of toolpath that I wanted to work with. Okay, what I can do from there is select everything, cutting feed, user defined, okay, and then I could say, all right, I want this to be slower, and then I can make it a slower number. This is just an example, one example of what you can do with the toolpath editor. You can literally select a group of toolpath and change the feed rate just for that toolpath, okay? There's a lot of applications for the toolpath editor, not enough to cover here today, or we don't have enough time to cover all of them here today, but that is an important feature in the software is the toolpath editor, and you'll find that in the CAM tree, okay? Under any operation, you can right-click, you can You got to go to the operation. You can right click, you can go to edit toolpath, and that brings up the toolpath editor, and you can use the different features in there. Okay. Now, the other thing that you can do again is you may have a group of features, and some of them you may want to post, and some of them you may not want to post. This could be lettering or numbering. Sometimes different part configurations need different groups of code. All right, guys, give me just a second here, okay? All right, sorry about that. Okay, so you may not need to post all your operations, so how do you segment or how do you turn them off? You can go to any feature, right click, post yes, no, and that will turn off that feature, so that way it will not be posted. Okay, so this way you can control what is posted and what isn't posted. The other thing that you have here as well is you have a group. You can use a group to organize your CAM tree. Sometimes they can get pretty, depending on the part that you're cutting, you could have 20, 40, 50, 100 features, and using groups is a good way for you to organize your CAM tree to make it easier to turn on and off features, to blank or unblank groups of toolpath. You can also even create toolpath patterns where you have multiple instances of that part. In other words, you can program one and make copies. Okay, so those are some of the options that I wanted to cover with you here. We did talk about our standard pocketing, open pocketing, inside open pocketing, and rest milling. We did contour ramping and side roughing. We talked about the tapping database. For drilling holes. We talked about working with wireframe, end surfaces, and hole groups to control where it's cutting. No problem, Tony. We'll see you next time. And then we also talked about the different selection methods for whether you're working with wireframe, surfaces, or solids. Okay, so that's the time that I have for you guys here today. Unless there's any additional questions that you guys may have that you'd like to see me address. Otherwise, I'll leave the open forum open for a minute. But again, I really appreciate you guys spending some time with us here. If you guys are looking to learn the BobCAD system, there are a lot of resources that we have available. We have a Facebook user group for BobCAD After Dark. We also have our YouTube channel. We do a number of webinars for our customers as well, our support and Advantage Plan members. We have weekly webinars that we do covering all kinds of topics. We have a video training program, a box set of DVD videos that covers all the features of the software. So there's a lot of options for you. Okay, so if you're new to BobCAD and you want to get the most out of it, again, or if you're just getting started and you want to learn more about BobCAD, give us a call, 877-333-4903, extension 123. Set up your own personal one-on-one demo with us. And again, that's 877-333-4903, extension 123. Okay. All right, guys. Look forward to seeing you in the next one.